Good afternoon, everyone. Welcome to this joint webinar on Splunk SOAR, Roar with SOAR, how to drive efficiency in your SOC. This webinar is sponsored by Splunk and powered by iValue. First of all, I would like to thank everyone who took their precious time from their busy scheduled day to join this webinar. Today, we have two dignitary speakers from Positka. Mr. Murugan is a Splunk SOAR consultant, and he is working in Splunk SOAR from last 5 years and also in the IT field from last 12 years. Then we have Mr. Vikesh. Mr. Vikesh is a Splunk SOAR architect, and he is working in Splunk SOAR platform from last 3 years. So in this webinar, we will have a few polls at the end. So I would like to ask everyone to please be to the end because there is some prizes who show the maximum engagement in the webinar. I think I'm good to go. Over to you, Murugan. Will you please take over from me?
Thank you, Vikesh. Vikash. So good afternoon, everyone, and welcome to this webinar. Thank you for joining. So for today, we will be going through, the value of having a SOAR in a SOC environment, and we'll be taking a look at SOAR. And we'll be taking a look at the live demo of SOAR. So during the presentation, if you have any questions, or even during the demo, if you have any questions, feel free to stop us, or you can also use the chat box to paste your questions. So without further ado, let's get started. So for the agenda, we will be taking a look at the challenges of faced by SOC today, and followed by how to automate with SOAR, and then building a SOC with SOAR, and then we'll also take a look at a use case, and which will be followed by a demo of that use case. So challenges in today's SOC. So SecOps is actually a combination of security and IT operation professionals who are a highly skilled team focused on monitoring, assessing risk, and protecting corporate assets, right? So they often operate from a place called Security Operations Center, or what we know as SOC. So combining security and IT operations into a dedicated SecOps team enables an organization to rapidly and intelligently predict and address security concerns. So cybersecurity attacks are now on the rise. We continue to see an escalation in the volume of attacks and the impact of the data breach, which only seem to be getting worse day by day with the advancement in different methods of attack. Also, the new challenge of supporting a largely remote workspace amid the pandemic and beyond only makes threat detection and prevention more difficult. So staying ahead of attackers is a constant battle for every organization, and the cost of doing this is becoming unsustainable. So there's rising amount of alerts in every organization, and then there is rising amount of cost as well. So organizations therefore rely heavily on a dedicated SOC team, to hunt for these, threats, detect and prevent and mitigate cyber threats. So, but the SOC team, generally across different organizations struggle. And why do they struggle? Right? There are numerous, reasons and challenges why a SOC team can struggle. We are highlighting 3 key and common reasons why a SOC can struggle. So the first one is skill shortage, one of SOC's biggest roadblocks. SOCs have been grappling with high amount of skill shortage. A high % of the organizations appear to have difficulty in obtaining, funds and also finding talent in the market, and in order to maintain adequate capability. So the human analysts are critical to the SOC to quickly identify, prioritize, and respond to incidents. While there are tools that are available that can help gather, analyze massive amounts of data in a quick time, human experts add the context and the situational awareness that is needed. The second challenge is the rising volume of alerts. So more enterprises see more than 10,000, 10,000 alerts per day, and analysts spend much of their time downgrading these alerts, that are misprioritized or determine alerts to be false positives. So analysts actually waste their, most of their time, almost like half of their day looking for problems that are either insignificant or not really problems at all. And then the third challenge is the lack of time. So with the rising amount of alerts and the disparate solutions, analysts have to switch between screens. They'll have to switch between tools, log into different places, and to do repetitive tasks, which is very time consuming. And to do that for alerts that are not really problems at all is really a waste of time. So time is really the third challenge. So according to a survey by Cisco, due to a combination of this talent scarcity and the alert volume and time, only 50% of the generated alerts are being responded to. And out of those 50%, only half of it turns out to be legitimate alerts. So automation with SOAR. So SOAR stands for Security Orchestration, Automation, and Response. This actually refers to a collection of software and tools that can allow an organization to streamline security operation in three key areas. So there's threat and vulnerability management, there's incident response, then there's security operation automation. So security automation is the automatic way of handling security operations, related tasks. It is the process of executing tasks such as scanning for vulnerabilities or searching for log without human intervention in an automated way. This is typically done with the automated script with the extensible product integrations that are called by playbooks. So there will be playbooks that will run and call these scripts that will automate the tasks. So security orchestration refers to the method of connecting these different security tools that an organization can have in an environment and integrate them with the platform. So it is a connected layer that streamlines security processes and powers security automation. So here's where we create workflows in the form of playbooks that have logically organized plan or actions for a security incident. So when there's a security incident, the playbooks are the flows that will get executed upon the security incident that will have a predefined set of actions or steps to be taken on a particular incident. Yes, Ranveer, we will be taking a look at Phantom. Sorry, there was a question from Ranveer about whether we will be taking a look at Phantom. So yes, during the demo, we will look at Phantom and we will look at the use case in Phantom, how Phantom runs the playbooks and handles the automation part. Okay. And then there's response. Response is nothing but case management, keeping a record of what actions or activities that are taken by the platform. So it's basically a record of the process and the results of each and every step that has been taken. So playbooks and workflow. So playbooks are basically a defined set of rules or actions. A playbook typically can contain at least one action. So and the playbooks are actually triggered by events that are coming in. So there can be SIEM solutions integrated with the SOAR platform that can send events or alerts. And once the alerts come in, these playbooks that are digital codification of human incident response plan can execute on that particular incident and then take appropriate action according to the workflow. So this can be as simple as tagging a false positive incident or updating threat intel or creating tickets in an external platform like Jira or ServiceNow and then linking them, finding relationship between tickets and linking the tickets, etc. So these playbooks can be executed manually by analysts by logging into the SOAR platform, or they can also be executed in an automated way. So this is a typical example of a playbook workflow. So this is how an architect, a SOAR architect, would design the workflow, and then this would get implemented as a playbook in a SOAR platform. So building a next-gen SOC with SOAR. So typically in a SOC environment, so every SOC environment will have point solutions like firewall, IDS, IPS, endpoint security, WAF, etc. And then they'll aggregate all of this data into central log management system or an SIEM solution. So on that SIEM solution is where all the correlation will take place. And the result of that correlation are security incidents that will be fed to a ticketing system. So that's where all the decision making will happen. So the level 1, level 2, and level 3 analyst will take decisions and then actions that needs to be performed on the endpoint devices. So the actions can be like blocking a firewall, blocking an address or an URL on a firewall or a proxy, taking in system offline, things like that. So currently in almost all SOC on all organizations in SOC, the part that is automated is the data coming into an SIEM and the SIEM finding security incidents. And once these incidents are identified, the rest of it is manual. So if it is a legitimate incident, so it the analyst will report that incident, which will validate. He will report. It will go into a process where the SOC manager and the management approves the response, and then the response is taken. So this is a very time-consuming process since it's driven by humans and in a manual way. So with SOC, right? So all the manual part can be automated. So all the repetitive actions that an analyst takes, right, on a daily basis can be automated, which will save analyst time by a huge extent. So examples are like creating tickets, linking tickets, updating threat intel, right? So all of this can be automated by the SOAR platform very easily. So a list of integrations that are available with the SOAR platform. Of course, we're going to be taking a look at the Phantom SOAR, and these are integrations that are the more common integrations that are available. We have more integrations than what is listed here. So let's understand the use case before we jump into the demo. So a phishing attack is a very common type of attack, and the number of attacks in every organization is quite high. 95% of all of all attacks is in an organization is phishing attack. So when there is a phishing attack, analysts will have to, first of all, download the email. They'll have to look into the details of that email and then manually run a lot of checks. So they'll have to use platforms like threat intel platforms like VirusTotal, etc. And then they'll have to, in case an email needs to be traced, they'll have to reach out to the email admin and ask him to run a trace on the email and then identify where and all the phishing email has landed, and then take delete actions, right? So all of those actions would need a lot of discussions and approvals, right? So all of this, with the SOAR platform can be automated very quickly. So we'll see how the automation happens, right? So we'll compare it with a manual way and an automated way. So typically the approach to a phishing response is a security analyst gets the email, downloads the email. So whether it is from a common mailbox or from the user's mailbox, the security analyst must get the email first. And then once he has the email, he's going to look for indicators within the email. So he's going to look in threat intelligence platform, SIM platforms, and he's going to do malware analysis. And based on the results, so he's going to take actions, quarantine actions like on EDR, or he's going to open a ticket, or is going to raise the severity or to escalate it. So typically these are the actions, and it's a very time-consuming actions. So when this is automated in SOAR, so the SOAR can automatically extract the email. It can do all of the threat intelligence thing. It can check against the, you can do malware analysis and everything in an automated way and take the response. Right. So if you take a look at the process time, right? So when it is done manually by a human, so that typically it takes about 75 minutes to create tickets, to check the URLs, analyze for suspicion, do scanning activities, search for similar emails and things like that. So it will take close to 75 minutes. Actually, in real time, it takes more than that, right? Because there's going to be multiple teams involved, not just a security team. But with an automated platform like SOAR, with all the integrations available, so all of these actions can be taken under 2 minutes. So it saves a lot of time, and by saving a lot of time, we're saving a lot of money. So with that, I will pass it on to Vikesh. He will take us through the demo of SOAR, and he will take us through the phishing use case. And by the way, before we go into the demo, let's do a quick poll. So Vikash, if you could please bring up both polls, one after the other.
Sure, definitely. Hello everyone, I believe you all can see a poll in your screen. Please do engage with it and provide your valuable feedback on it.
Oh, sorry, I was speaking on mute. So yeah, so there was a question on whether Phantom is available as cloud native deployments. Yes, Phantom is available as both on-prem and SaaS solutions. Okay, so that must have been a typo, Ranveer. Okay. So if we are done with the poll, then it's over to you, Vikesh.
Thank you very much, Murugan. It's a nice presentation on phishing investigation use case. So let me quickly start sharing my screen. So yes, hello everyone. Thank you everyone for your time for joining this webinar. So my name is Vikesh. I am working as a Splunk architect at Positka, Splunk and SOAR architect. So basically, right, Splunk SOAR is a market leader in security orchestration and automation response. So it enables the organization to improve their security and also addresses the risk, like managing the risk for better orchestration the investigation responses. So basically, right, this will also help the security team to scale faster and manage the ever increasing load of incidents. So today in this demo, I just want to walk you through the Splunk SOAR, how the platform looks like and what we can do with this. Also, I would like to show you how individual steps can be automated. Along with that, how we can build a sophisticated, repeatable process that can be put in place for improving the security as well as for the investigation and response plan. So before I move on to the other screen, just I want to quickly go through the what we can see in the screen. Like so, this is the home screen of the Splunk SOAR platform. Um, we can see the top panel talks about the ROI summary, which we can configure it. Below, we can see some of the dashboards, which talk about the events, the workload, what are the status, whether it's resolved or unresolved, some of the playbook actions. And we have much more information very detailedly about all the operations that's been on the SOAR platform. Like at the bottom, you can also see if there's any SLA breaches, or is there what is the average of SLA for each of the container that's created on SOAR. So to give information, right, in SOAR, we call the event as a container. So the events are called as container in SOAR platform. So before I move on to the next screen, I just want to talk about the sources. So SOAR starts with the data source. So what we call it as an ingestion, the other term for getting the data inside Splunk SOAR. So SOAR can take both structured data, like for example, we can get the data from a SIM, like Splunk Enterprise Security, or else we can get the data from email like Office 365 or IMAP, where we can able to pass the data and extract the key value information. So there are plenty of SOAR apps through which we can get a variety of data sources into SOAR. So we will talk about the apps in a bit. So SOAR also has a fully functional REST API functionality where we can able to get the data into SOAR. So let's say you have a CSV file or you have a database with the API functionality, you can get the data into SOAR. So that is all about the sources. So in this demo, I just want to touch point on three key functionalities. So one about the first component would be the apps. So the integration between SOAR platform and the technology that you will be using in your environment. So second about the mission control view. So that's a hub for the collaboration of the security analyst where they can do the event management and case management. And third, I want to talk about the playbooks, which are codification of repeatable process. So let's get into the apps. So in Splunk, there are over 300 plus apps spanning across different product technologies, and they are providing the out of the box orchestration capability. So basically, right, every single SOAR app is a Python module, which adds a set of Python codes that will be used for authentication and performing the actions on the target devices. So these, in most cases, most of the applications that integrate through the API functionality, and also to call a few other methods, there are like SSH communication as well as like Windows remote management. So basically, like SOAR apps help us to gather data from variety of sources, as well it helps us to perform tasks on the target devices. So the SOAR framework, right? The SOAR framework has been designed, specifically the apps framework has been designed such that it is open, extensible, and flexible so that we can do the integration very easily. For example, let's assume that you have a proprietary security solution that you have built on your own. You want to do the integration with SOAR, that's very much possible. So we can easily create the apps with SOAR. It just open. We have a extensive documentation on SOAR how we to create an application to integrate your proprietary application. Along with that, right? It shows how to build an app from start to end. This is basically reduces the development cycle from days to hours. So it is just easy if the app that you will be creating just as a metadata results, which should be in the JSON format and the set of Python codes for the API functionality and data formatting. So the next good thing about SOAR apps is that these can be modified as extensive as you want. So these are all community supported, saying that the approach, right, which is like community supported, gives us about almost 30% of the apps are contributed by the product vendors, customers, as well as the support. So we have a SOAR app GitHub repository where we can able to take a look into all of the connectors which are readily available. So here you can able to see it's a search filter where you can just filter it out for the app that you want to look into. So for now, let me go into one application called Office 365 demo. So for each of the application, you can able to see the actions. So the actions are nothing but to execute on the target services or technologies to get the data or to perform tasks on the end targets. So as you can see here, right, there are a few of the actions that we can do on the Office 365, like we can block the sender, we can get email, we can delete email, and many more. So the beauty here is that the app action names are normalized across all of the API implementation and the apps. So this gives a very smooth experience for the user who wants to perform similar action across different technology or different apps. So for each of the app, you can able to see a asset. So asset are nothing but the configurations where we will define set specific informations to communicate with the end devices. For example, the Office 365, we have asset info, and we'll be providing the asset settings where it will communicate to the target device for performing the actions. Okay, so this is all about apps. So let me take a pass here. Do you have any questions on the apps so that we can answer? Okay, seems to be no question. Okay, let me move forward. So now let us go to the second scenario. Second key functional items which I talked about is about the mission control. Okay, so let's get into that. Okay, so the actual phishing scenario starts with looking into a phishing email that we ingest into Splunk SOAR. Okay, so let's look at the actual event of a phishing simulation and see how SOAR can automate the recurring phishing email which are gets triggered or get ingested into SOAR platform. So clicking on this particular container, right, is this a fish? So let's look into the container, which seems to be a phishing email that we ingested from the mailbox. Okay, so this is the mission control view that you get on the Splunk SOAR platform. So just going into the container, you can able to see the two views here, summary and analyst. Summary is a very simplified view, which is for the SOC managers. So that will give you a very overall holistic information of what the activities actions have been performed. Then we have the analyst view. So the analyst view will tell us all the activities, workbooks, guidance. So activities are nothing but the actions that we perform. Workbooks are nothing but the step-by-step action that we perform. And guidance, this is an automated way of giving some recommendation based on the data type. So let us navigate to the artifacts tab and see that we can able to see some of the artifacts that got ingested from the phishing investigation. So we can go into each of the artifacts to see. So this artifacts talks about the file name. Then we have an artifact for domain, and we have an artifact for email, and so on. So we have multiple artifacts. So let us look into one of the artifact which talks about the URL, right? So when clicking on this URL, we have the ability to directly run the action, which we talked sometime back, right? Each app has certain actions which we can run on the artifacts. So here we can see the request URL. So clicking on that, we have the option to run action, and we have all the IOCs displayed here. So what we want to do? So first, so this is a request URL. Typically, I do want to do a URL interpretation to see whether this is malicious or not. So I will just click on the URL interpretation. So this screen, the pop-up would take me to what are the apps configured or available which will perform the similar action like URL interpretation. So for this example, I will choose virus total, then I will just do a launch. So on the left, you should able to see the high level information. On the left, you can able to see the high level information of the action that got executed. if you scroll down, you can able to see the widgets. So this widgets will give us information about, so you can see, right? So the virus total flagged 3 positives out of 71 total scanning engines, which seems to be an indication of a malicious. So okay, if this seems to be malicious, next what I want to do, basically I just want to block this URL, right? So what I can do is that I can just pivot back to the request URL, run another action, which is like run another action to basically block the URL. So I can go and block URL. As you can see here, only one app is already configured. So just click on app and then you can launch it. So as easy as that. So on the left side, you can able to see that there's an action executed on Zscaler, and you also have the widget which shows that it has been successfully blocked. So what I'm trying to say here is that so these actions are partially automated but manually initiated. So now what we are going to see is that how we can create a fully automated way of executing these actions. So that is where the third key focus component comes in, which we call it as playbooks. So now let us take a look into the playbooks. So playbooks are nothing but the codification of reusable or repetitive actions. So those are built on the platform Python programming language. So as I told you before, right? Splunk supports community for playbooks as well as for apps. So we can see the repo, right? So these are repo from community. We can also create our own playbooks, which we can save it under local. Or if you want to contribute to the community, we can also do that. So that's how we can do. So now for now, let me do a quick, simple playbook that will have the automation process of what we done manually. So this is how the playbook looks like. We want to do the automation, so we'll go to automation. So every playbook will have a start and end. So just dragging the start, I can go with the action. So in this action, I know I want to do a URL repetition. So I can just go with URL repetition, and this will show the respective application which will have that action. I can just click on, and I have to input the parameter. So here the parameter will be the request URL. Done. So now what I did is like I just want to investigate the URL repetition and get the positives or hits. So after getting the positives or hits, I just want to have a decision making logic, which we call here as a decision block. So I need to analyze the result based on the number of hits. So I will just simply go with a decision block where I will input the summary positives. Where is that? Okay, we have to look into the URL repetition because we are getting the results from the URL actions. So from here, we can go and look for the summary positives. So what I'm doing here is that, see, I run a URL repetition, I can see a positive hits, and if my positive hits is greater than or equal to 1, then I need to obviously block the URL. That is the logic behind here, the reason of using the logic block. So there are multiple operators like AND, or you can use even the not or else if else if you want to decide based on them. So now I have done the URL repetition and I have analyzed the results, and I know that if the hits is more than or greater than 1, then I need to block the URL. So next action would be blocking the URL. So I can just go on action. I can just type for block URL. It takes me to the application which is configured. Then I need to input the parameter. So again, going to the URL parameter. That's it. So now the playbook is completed. So it's a very simplistic playbook for what we have executed manually. Now we are going to do it in an automated way. So that's it of creating a playbook. There are a few final settings that we have to do. One is to name the playbook. Just git check URL and block. We should do operates on. So operates on is nothing but the labels. So every data source will have a label. This is just for segregation of events. So for time interest, I'll just give a wildcard, which will map for all of the events. Then I will set this to active. Okay, so I will set this to active and I can save this playbook. So I can give a comment as initial build, then say done. So what we have built in this playbook is nothing but the manual action that we executed previously. So now let's go back to that investigation. So this is the one which we manually initiated actions. Now, if you see on the top, you have an option called playbook, where we can directly run the playbook. So just filtering the playbook. See, the playbook appears here. Then I can just run the playbook. On the left, you can able to see the playbook check URL block that we have created just now is executed and what are the actions. This gives you a simplistic idea of how quick SOAR is in order to execute actions on the ingested events, right? So you can able to see the results of each of the actions also. So what action have been performed and so. So how easy is that, right? To create a simple playbook for the repetitive actions that you want to do instead of doing it manually. So if you are getting an event from a mailbox, basically the mailbox has the events where the SOC analyst will forward the emails which are suspicious. Okay, so in order to triage those, it might require a human effort switching to different tools and services. But what we see here is that we are only in the SOAR interface console itself, and we are doing performing all of the actions for investigation and their response. So this is the beauty of SOAR. So instead of navigating to different tools and services, you can do all the investigation within one tool. Okay, so this is a very simplistic. It's a very simplistic way of creating a playbook for the time interest. So if you want to look into the actual event of a phishing investigation, the playbook can be complex. So as you have already seen, like Murugan explained you a phishing investigation workflow. So there may be multiple way of developing a phishing email investigation depending upon the requirement. So now let me take you through a complex real world phishing investigation. Okay, so we have already have it built. So let me walk you through the phishing investigation playbook and show you what happens in each of the phases. Okay. So let me zoom a bit so that it will be clearly visible. Okay, so here you can see that this is a real world example of a phishing investigation. So we are starting with a start block. Then we go ahead with running the reputation, like file reputation and URL reputation. And as we saw that we have a decision block which will calculate the risk scores or the positive summary risk or hits. Based on that, we will be determining the file if required, or for both of the file reputation file and URL, then we will go for hunting the file. Either it can be hunting the file or getting screenshot of the incident, or we can do a domain reputation. So likewise, right, it goes sequentially. So hunting the file, then we can get the system info. Once we get sufficient information, then we can block the URL. So at this phase, right, you can able to see a circular shape, which is nothing but the user prompt. So this gives the ability for the SOC analyst to handle whether he wants to proceed with deleting the email or he wants to do some more investigation. So after the response from the prompt, it goes to the decision block, which will check for the response, whether it is yes or no. If it is yes, then the playbook will execute a sub playbook called delete phishing email, and then the email will be deleted. So this is how the real world example of a phishing investigation will be. And this is not a unique, I mean, it can be one way we can develop the playbook as different as such, depending upon the requirement for every single environment. So the investigation can be in different ways how we define or develop the playbook. So now what we can do is that we can run the same playbook against the container to see how this playbook gets executed. So going on to the playbook, I just filter it for the phishing. Yes, so now I run. So now you can see, right, on the left, you can able to see how many actions are getting executed and within a fraction of seconds. So this is how the importance of orchestration and automation helps us for the SOC team. to scale faster and spend time in a more valuable way of investigation. So here you can see, right, all the domain reputation, URL reputation, all of the actions got executed. And as we saw, right, there is a user prompt which will let us know whether we want to proceed with deleting the email or not. Okay, so as you can see here, there's a system prompt in terms of a bill which I can investigate, and this pop-up will have details about the action name. So it shows that it's a phishing email detected. It also has a message whether we want to delete the email from the mailbox or we want to do an intersection manual. So for this case, I will just do yes. So once I do yes and I send the response, you can immediately see the next playbook, which is the delete phishing email is getting executed. So this message trace will get the trace of the email ID and it will run the query against the mailbox and it will delete the email. So, right, how cool is that? Right, we were doing all of the playbook execution actions in just a few minutes. So this is how we can leverage SOAR to increase to improve the security of an organization as well as improve the security risk by addressing investigation response in fraction of seconds. So basically, this will help the SOC analyst to scale faster or spend their time in a valuable way of investigating other action of times. So yeah, that's it all about the playbooks. So what we have done so far, so in this demo, we have ingested a phishing investigation from an Office 365 mailbox. We manually performed some of the actions and we created a simple playbook to the repetitive process of those manual actions. Then we have executed a complex phishing investigation and we have performed the operation. So that's it. So I think this is all about an example of a phishing investigation and how you can get benefit with SOAR in order to reduce the investigation time and a response. So I think I think I will take a pause here. If any questions, please free to shoot out.
So yeah, because there was a question about the features of the new virtual playbook editor.
Okay.
So can we go there? Can you try creating a new virtual playbook? I mean, in the a playbook in a new editor.
Yeah.
So Nishan, to answer your question, yes, the flow has been changed. So now, as you saw, there are two types of playbooks that we can create in the new virtual playbook editor. One is the automation, and the other is input. So basically, just parent-child playbook. So they've renamed it that way. So when you create an automation playbooks, that's the one that will run on the events themselves, and the input playbooks will be called by the automation playbooks. That's the difference. And a small change is that you don't have to click on edit playbook. So in the old version of the virtual playbook editor, you have to click on edit playbook, and then only then will you be able to edit the playbook. But in the new virtual playbook editor, you can make changes on the fly and just click save. As simple as that. Okay. Yeah. So out of the box, there are a lot of community playbooks. So community playbooks are like a reference. You can directly use it in your environment if it is applicable. But most likely you will end up making a few changes here and there to fit it to your need. Okay, so there was a question about whether we can demonstrate an IP reputation and do that for all future events. So let me share my screen and try to do that very quickly. Just a second. Okay, sharing window. Share my browser. So for that, we will first need an event. So I'm going to create a sample event. Let me call this webinar sample. And I'm going to save it as event. So within the event, there should be an artifact with which we need to run the actions on. So typically all of this would be pushed in by the SIM, but since we don't have that at the moment, as this is for a demo, I'm manually creating it. So let me create an artifact called IP address. Let's call the name as source address. And for the IP, let me use my IP. And I'm going to click save. So now let me go to playbooks. I'm going to create a playbook. It's going to be an automation playbook. Let me call it one. So I'm going to select action. So when I pull on this blob, I'll be presented with a lot of options. I can select actions from the option, and I have a lot of integration. So I'm going to use the virus total integration to run the IP reputation check. Actually, before that, let me first filter down to the exact artifact that I want to use it on. So I'm going to select artifacts, and in the artifacts, I'm going to select source address. So when I do that, only this artifact will be passed on to the next block. Source address, and I'm going to say not equal to empty. I'm going to leave that empty. And the next action is going to be a virus total reputation check. I'm going to use the asset. So the assets should be pre-configured. I've already configured it with the API key. So I have two assets. I have two different API keys. So that's why I have two assets. So I'm going to use the second one. And for the IP, I'm going to select the filter artifact. So I'm going to click on filter here. Earlier, if you had seen, I clicked on artifacts, but now I'm going to use the filtered artifact from the filter one. And I'm going to select source address. Right, and then I'm going to connect it to the end block. So as simple as that. Save. I wanted to operate on events because that's the label I used when I created the container. So the playbooks is governed by the label, so it will run on the label that it is configured to. Click save. I'm going to enter a command. Now there are two ways with which I can run the playbook. I'm going to show you how we usually debug. So this is used when developing the playbook. So from here, I can simply use the event ID number. So the event ID is 75. So I'm going to run the playbook on 75. Run test. So it has run the reputation. So we can go back here into the container and go into the list of activities and take a look at how this says, take a look at the results. So you can see that totally 88 checks were run against this IP address. So for the, just try to check it for URLs, and it has found that there is one positive. Right, so this IP has been listed as positive by, in the threat intel platform by one of the feeds. Not sure what feed it is, but it is. So there's only one positive. So this is how you would run an IP reputation. So we can set this playbook also to active. So when we set it as active, so any containers with the event label, if it, if there's any container that comes in with the event label, this playbook will automatically run on it. So yeah, that's it. Any further questions?
So I think we are done from our side. I mean, the demo part is already done. Murugan has already talked about its business side and its capabilities, and Vikesh has showed a lot of playbooks how to handle different kind of things in security and other fields. And in the meanwhile, you can also email us at suzanne@positka.com if you have any other queries. So thanks from our end. Murugan, do you have anything to add? Murugan, Vikesh? Thanks all of you. Murugan, do you have anything to add? We are just about to end it.
I'm good, Vikas. Thank you very much. Thank you everyone for joining.
Thanks everyone.
Have a nice rest of the day.